Well, hello everyone, and welcome to the September 2023 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. We don't maintain a formal membership list. Our normal meeting date is the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to be able to organize a meeting in December. But you can meet us at any of the other months. So we have 11 meetings every year, or so we try to. When we meet in person, you can join us for food and social at 6 p.m. and the presentations start at 6:30. And when we do meet in person, our normal meeting location is in the Object Computing Incorporated training room. That's at 12,140 Woodcrest Executive Drive, Suite 310, and that's in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Allspaw, that's me in the middle, Wei-Chi Gao, and Kathy Zwang. You can reach all of us on the steering committee if you send an email to that address there at the bottom of your screen. That's javasigsc@ociweb.com. And I'd also like to send a shout out to our newest member, and he is Robert Levitt, who has just recently joined us on the steering committee. The St. Louis Java Users Group would not be possible without the support of our drug sponsors, so I've got the logos up here on the screen. So from left to right, top to bottom, we have Object Computing Incorporated. They are our original sponsor from 1997. Yes, we're one of the older jugs. We've been around for a long time. And JFrog is another one of our important sponsors. They have been paying for the Zoom subscription that make it possible for us to be able to meet remotely. So thank you very much here to JFrog for making the remote meeting part of it possible. Signature Consultants and Adaptive Solutions Group are both headhunters. So if you are looking for a Java position, or you have a Java-related position that you would like to fill, just do a quick Google search on those two, and you'll be able to either perhaps fill the position or find a job through them, and let them know that you found out about us through the St. Louis Java Users Group. At the end of this meeting, we will be raffling 2 JetBrains licenses of your choice. And if you're watching the recording, I'm sorry, you must be present to win. That will be after the presentation. So thank you to JetBrains for sponsoring the JetBrains licenses. Elastic has also sponsored gift cards for us in the past. Intertech is a training company, and if you're looking to update your skills on various technologies, just do a quick Google search on Intertech, and they have lots of training videos that you can use for all kinds of the latest technologies. They sponsor the so-called Screaming Flying Monkeys. Oh, they're a lot of fun. What? Screaming Flying Monkeys? What are those? They're just little dolls, and if you throw them up against the wall, they make kind of a little screaming noise. They're a lot of fun. But they also sponsor some coffee cups and mouse pads and ballpoint pens and things like that too. And also at the end of this meeting, we will be raffling 2 Manning ebooks of your choice. And again, if you're watching the recording, you must be present to win on those. Pearson also will sponsor physical books as well for us. So thank you to all of our sponsors. As far as announcements go, later this month, we have the Strange Loop 2023 conference that will be meeting at St. Louis Union Station here later this month, September 21st through the 22nd. So if you want the details on that, you can visit their website at that address there on the screen. That's The Strange Loop .com, and I'm told that that may be their last conference. So that may be the end of the line here for Strange Loop, or so I'm told. So if you want to keep up with our presentation schedule, it's easy to do. Just watch our meetup site. That's meetup.com/gatewayjug. And as we update our presentation schedule or change our location, that will all be posted there. And as soon as a meeting is posted, it's okay to go ahead and RSVP on Meetup so that you can get a reminder. Now, if you are interested in giving a presentation, or if you would like to become a Jug sponsor, that's easy to do. You can just email us at the steering committee at that same address that I gave you before. That's javasigsc@ociweb.com. So that wraps up my announcements here for tonight. And so for tonight's presentation, we have GraphQL from the ground up by Jason Clark of New Relic. So what I'm going to do is I'm going to stop sharing my screen here, and then that will allow Jason to share his screen. So why don't you take it away? And if anybody has any questions, I gather you can type them into the chat.
Cool. Thank you, Bruce. All right. I think things should be shared there. And I am keeping the chat window open where I can see it. So if anybody has questions as we go along, do feel free to write them in there. Depending on the context, I may postpone an answer later or talk about it at the end, or I might do it right there as we go. So feel free to hit me up. As mentioned, my name is Jason Clark. The talk will be recorded and available later as well. I work for New Relic, an observability company, and there I'm a principal engineer and architect. I've done a lot of different things at the company. Right now, I work on our logging product specifically. And so this talk really came out of New Relic's adoption of GraphQL as a key technology for us. It's at the center of how we present our APIs to our customers and to our own UIs. And so there's a lot of good stuff that we get out of that I'm happy to be here and share with you today. I do want to give a special call out as well to Elena Lopez, former coworker of mine now with Google, who helped me make the initial version of this talk. We used to give it together. She's in Zurich now, and time zones are not friendly. So appreciate the work that she did on that back in the day. So let's get started and let's talk about where we're going to head today. So GraphQL, first off, we're going to define what it is. You may have heard the term, you may not be familiar with it. So we're going to kind of dig into the definition, dig into a little bit of what's in here. We're going to talk specifically about why you would choose it, because it is a technology like any other with strengths and weaknesses. There are trade-offs about using it, and we'll dig into what those are and what might send you in the direction that New Relic did of choosing to adopt it, or what might make it not work for your use case. In the third part, we'll look at how you actually build a GraphQL service. We'll take a look at some of the nuts and bolts. There'll be a little bit of Java code, some pointers out to places where you can find more resources and libraries and examples. And then we'll end with kind of an experience report of what it's been like for us at New Relic adopting this technology and being several years into making it very central to the way that we do business. All right, so to begin with, what is GraphQL? Now, you might have heard of it on the internet or heard it referred to in various places. I know my initial thing about it, I thought that it was some front-end JavaScript-y sort of technology, and I ignored it for a while. Then it came up at New Relic, and I found out that it is actually much more than that. It is something that crosses a lot of different languages, a lot of different parts of the tech world. And it's way more than just the sort of roots that it might have had in JavaScript. So there's a couple of big ideas that GraphQL is really about. And the first one is to serve as kind of a replacement for RESTful services. Now we can get into long arguments about what is RESTful, what isn't. In this context, I really just mean the idea of like, okay, independent little HTTP services that you go and contact for a particular piece of data or a particular service that it provides. And what tends to happen as an application or an organization grows is you get often more and more of these services. Microservices is a pattern that people are very fond of, and it, make little pieces that do all of these different things. Well, that kind of has some big downsides as you scale bigger and bigger. Here we only see 3 things, but what if we had 50 services? At some point, it gets really difficult for your client, be it a browser or a mobile application, to manage all of those services, know where to call them, know all of the different formats. Oftentimes, all of those different services might be a little different from each other. They might have different conventions, paths, data formats. So this is really at the heart of what GraphQL was designed to fix. It came actually out of Facebook, and they had exactly this problem of a proliferation of different features and teams, and they didn't want to have their mobile app or their website have to look to all of these different places. They wanted it to just be able to talk to one location that would federate out and provide all of the pieces that they needed. So that is what the center of what GraphQL is about sort of decoupling the idea of where your data comes from the query language and the transport that you're using for it. So at New Relic, for instance, our implementation of it, we have one central GraphQL service that you talk to. There is no longer a set of all of these different paths and different domains that you need to call into to get different parts of our system. They're all centralized through that GraphQL service. But there's a lot more to it than just that, like making one big Uber service facade for something like by itself isn't super compelling, but GraphQL brought some other tools to the table to help us deal with the complexities that come with making a service that is like that. And in fact, this wasn't just an implementation that was done by Facebook. They have a spec, which is now out in the wild. There's a foundation that manages it. It is done in open source to define the GraphQL language and the protocols that are used around it. So GraphQL now has implementations in many, many different languages, one of them being Java on the JVM. And so you can both author and consume GraphQL from your language of choice and get a lot of these benefits that come from how the system is structured. All right, so I mentioned that, part of what this is built around is giving you better support for large scale sort of services, large surface areas, and putting that into a single thing. And part of how it accomplishes that is by a type definition language. So GraphQL, one of the big components of it is how you define the types that come back from your from calls to this service. Now, that is as opposed to REST, where it's like, well, I don't know, you make an HTTP call and I give you a blob of JSON. Hey, maybe it'll always have the same thing in it. Maybe I'll change it. There's no guarantees built into REST. It's at a lower level than that. So GraphQL really sort of steps up that abstraction hierarchy and provides us a language for defining what our data and responses, requests and responses look like. So at base, the type system in GraphQL starts from basic scalars like you would expect. It's got integers, floats, strings, booleans. It has an opaque ID type, which is a nice little thing that they've done to sort of keys apart doing your IDs as integers all the time. There's a type to represent it. Now, scalars aren't going to get you very far in a service, so obviously you can define object types. These object types are, arbitrary sort of objects, the way that we think about them, a lot like we think about them in Java. And we'll see later on how some of these things map. Types have a field and the fields, and then those fields have types themselves. Everything in GraphQL is typed. Everything has a precise type that you can associate with it. So in this case, our example that we'll be using throughout this, it's a movie type. It has an identifier that would be, the primary key for our database. It has a title. For now, it has the budget. Maybe that integer ought to be a long the way movies are going these days, but we'll get there. So you define the shape of the objects that are your data model, your system. There are also custom scalars You can make your own types for scalar types and add them in. One in particular that is very common that people want is stuff relating to dates and times. Those are sort of not included in the base spec. And so these are opaque values that you pass back and forth, and your server has to know how to interpret them, but you can express them in your type definitions very clearly and give that language around what your data is going to look like. So list types are also natively built in. So putting square brackets around the type means it's a list of these things. So here we have a list of reviews. Those reviews have an opinion someone can write and a score as an integer. And then our movies now have a list of reviews that are associated with them. This is all very, very clear, basic sort of object modeling that this type system provides for us. It doesn't have some of the super sophisticated things that sometimes show up in type systems. It pretty well is built to let you naturally model your data to be handing back across the web. So one thing where this kind of diverges from the sort of fields on an object sense that we've gotten so far is that any field can take arguments in addition to being callable by itself. So here we have a reviews field, and now it can take a score so that you could say filter on the score for the reviews that we're going to hand back. You can kind of squint and see that this is shaped a little bit like a Java object having a method call that you provide arguments to get the response rather than just a raw field that's on there. But within GraphQL, they're shaped a little bit more similarly to each other in how they're presented. In this case, we would hand in the score as an integer. And an important thing to note is that all of these types that we've seen to this point are nullable. You can express that a given field that comes back or a given argument has to be provided by providing an exclamation point to it that says this is required. And so then you can enforce those constraints. We'll talk a little bit later about some of the consequences of doing that sort of enforcement because it is an interesting thing as your schema grows. Enumerations are provided out of the box, so you don't have to hand around just arbitrary strings. This allows for the schema to do some amount of sort of validation if you've got something that's enum-like. These are more of the classic sort of enums where they're just a list of values. They don't have any of the sort of fancy extra data properties that enums have in Java itself, but they are very useful for expressing those sorts of common constants that you might have in your application. Okay, so this isn't everything that's in GraphQL's type system, but that's the basics. That's what the objects look like. That's how you model the data that we're talking about. How do you actually get that data? I mean, it's all well and good to say, hey, I have a movie object, but where do I go and actually get it, and what does that process look like? Well, in typical usage, GraphQL is transported over HTTP. And so here's a very basic little curl where we can see a request and then response going on to a local GraphQL server. So the path being /GraphQL, that's fairly conventional as the location. There's a content type for saying, I'm going to send you a GraphQL query. There are other encodings that can be used. And then you provide as the data in a post to the server what your GraphQL query is, and then the response is a JSON object. It's JSON data that comes back. And we'll expand this out, and we're going to look a lot more closely in just a moment at what these pieces look like. But at the base, this is pretty common stuff. It's pretty normal sort of calls over HTTP, and that's very powerful because it means a lot of tooling and a lot of things that you already have for dealing with HTTP systems are equally applicable when you move to GraphQL. You don't have to get rid of all your tools just because you're moving some of these systems to this more advanced querying system. So we had seen the movie type where we define our object, but like it's floating in the void. It's nowhere. How do you get one of those movies? Well, the way that this works in GraphQL is that there is a root type called query. Every GraphQL service has to define its query type. And that query type is going to have fields, which are sort of the entry points that you use to get into the system and start getting data out. So here we've defined a movie field. It takes an identifier. We're going to look up the right movie for it and return you back the movie object that's for that. This query can have as many fields as you want. They can take arguments. There's a whole bunch of richness that you can build in how you do that. And then those subtypes can have objects on them. And so this can be as deeply nested and, as the name implies, graph-like as you want. You can have connections between different objects expressed through this. Now, with that query type, what this translates into is the text on the left is an example of the query that you would write asking for the data. So you say query, give it curly braces, ask for movie, pass the ID, list the fields that you want off of that movie that comes back. And on the right, we see what is the response that we get from the server. So there's a data key that you see at the top. And then under that, everything aligns to what we asked for in the query. So we can see that movie, ID, title, all of that is one for one pretty much with what we had asked for over in our query. We'll come back in a moment to why we have that data key up at the top and have that extra indirection. But the important point here is that this response is shaped based on the query that we gave it. And this is one of the superpowers that GraphQL has over a RESTful system where there's not a lot of convention. If you want to say, hey, I don't want all of the fields, I want the data like this, you could come up with custom ways of doing that, but there's no standard. In GraphQL, this is built in. So if instead we said, hey, give me the movie and all I need is the ID and title, that's all that it's going to hand back to you. You will only get the fields that you explicitly ask for. And in fact, there is no wildcarding. There is no way to say, give me the object and give me all of the things on it. The only thing that you can do is ask for precise fields. And this actually is a really powerful thing for the evolution of the system. Because part of why RESTful systems often, when they are very loose, can cause breakage is like, well, okay, you can add an extra attribute into the data. Is that going to break anybody? Who knows? Who knows how they're reading, how strictly they're reading those things, whether they're mapping it, their Jackson mapping says, I know all the properties, and if anything unknown shows up, blow up, right? With GraphQL, it forces you to be explicit, which can be a little tedious at times, but then it means that we can freely add to the schema later without fear. We know that any caller that wants to use the new properties that we provide has to ask for them, and they're not going to be surprised. So querying, all well and good. As the name implies, it's convention that you should not be doing writing operations when you're calling query. Query is meant to be read-only. So the flip side of that in GraphQL is called mutations. So much like there is a query type at the top, there is a mutation type. And this is intended as the spot that you put anything that is going to modify your system, thinking in sort of a CRUD sense, the create, update, and delete. All the things that aren't reading should be modeled as mutations. Can you ask for all movies containing a word like space? Yes, you definitely could. So that would be a matter of how you model the field. So what it does with the parameters that you hand in, you get to decide what the semantics of that actually mean. And so like at New Relic, for instance, we won't have an example of this here, but we actually have some fields which are specifically search fields. And they're meant for doing sort of arbitrary lookup for things. Some of the others are modeled more like just strict data. It's like, okay, what user, what account, what things are there. And so the meaning of what these fields mean is very much up to you and your domain. It's only the type structure that GraphQL kind of tries to enforce. So here with our mutation, if somebody wanted to write a review, this would be the form that you would want it to take. Now, it's kind of annoying to have to write everything out as scalars. And so there are actually types provided in the system for doing input to arguments. And they are separate from the response types. And this is another one of those cases where GraphQL has made a decision to sort of enforce something that you should probably be considering, which is that, they don't want this to just be, you take your database model and just slap it into the GraphQL service, right? They want you to think about how these things should be modeled. And sometimes how you write data maybe should be a little different than how you read data, or there may be different cases of writing data in different shapes that you want to consider. So those input types allow you to model the inputs to the system. And this is inputs to arguments both on mutations and on query. So you can have richer objects. They tend to show up more often when you are writing the mutation side, because they're often, putting the big payload of data in that you're trying to write out. In this case as well, you'll note that we have the exclamation mark. So this enforces that you have to actually provide us input. You have to actually pass that in. You can't pass a null review. And then the GraphQL server automatically validates that for us and makes sure that we provide what it's expecting. Mutations, when they're actually applied and you run them against the server, they look an awful lot like the query side that we already said. So we start with our mutation on the left. We say mutation, give it the curly braces, call the different fields off of that mutation that we want. We get responses out of the mutation. So here we're asking for the title that comes back from the movie that results from our creation. And here, if we were creating that review, it'll give us the title for the movie that it looked up. So your mutated, there's a lot of sort of parallels between the query and the mutation side, but it sort of makes you think about them as separate pieces in a way that I think is often healthy for good modeling of the data. So that's how we get data into the system. That's how we get data out of the system. Unfortunately, as we all know, things don't always go to plan. And GraphQL grapples with that as a first-class thing. Errors are baked into the GraphQL system, and how you deal with them is specified. It's in the specification, and it gives a lot of power by doing that, of making those things very consistent. So we saw earlier that there was that data key that's at the top of the response that we get given back. Why there is a key there instead of just the beginning of the data that we have is because there is another top level key, which is dictated by GraphQL as being supported, which is the errors key. That errors key is going to be an array of error objects. They will at minimum have a message. Most of the time, they will have a location and path that's being provided to tell you where the error came from in the query that you handed in. But this gives us a very consistent structure for being able to handle those errors. And not only just handling errors, but handling multiple errors. This is, again, one of the things that GraphQL recognizes is like, if you have a failure, if you've got a query and it's asking for multiple different things, it's possible that you could have more than one error. And this gives us a structure for being able to return those errors because it is, by definition, it's an array of them. We may have multiple failures. It also allows for you to extend it. There's, obviously a recognition that not everybody's system is the same, not everybody's errors are the same. We all may want some extra information. And so there's an extension key underneath each of the errors, and that is for you to add whatever makes sense to you to put into it. So for instance, a common one that we've done at New Relic is we have an extra sort of codes about the error to classify them, so we don't have to like look at the messages and sort of scrape around. Now, that's in part because GraphQL gets away from the idea of HTTP status codes. And we'll talk a bit more about some of the tension over that. But again, the key thing is like, you may have multiple failures. There may be multiple things that go wrong. And so a single status code doesn't represent the state of what happened with a given query in its entirety. You need something richer to be able to show that. So This does lead to one of people's least favorite things, or what you'll hear cranked about on the internet a lot about GraphQL. And that's the fact that a response from the GraphQL server will be an HTTP 200. It's going to hand you back a payload. Now, that payload may be in the GraphQL spec all errors, like the one that we just saw before this. It's not quite as bad as this, of like giving you a 404 back in the middle of a payload, but it is something that takes some getting used to. But what we found at New Relic is that leaning into that and into the reasons why GraphQL has made that choice and designed things that way has given us a lot of benefits in making a system that is more understandable and easier for our users to navigate when they're working with our APIs. So along those same lines, you might have multiple errors that happen. You may also have things that partially succeed and partially fail. It doesn't really represent it super well here with only a couple of keys, but if you can imagine, New Relic has almost 50 different services that are backing the main front of the GraphQL. If you make a call that asks for things from 10 of those, who knows? Part of it might be there and part of it might not. And so GraphQL by design allows for that by saying, hey, you can get data back and you may get a partial response with what could be filled out, and then you'll get errors that fill out about the parts that are not. So this is part of the power that comes with the way that GraphQL has modeled errors. Had a question in the chat about sending a 504 or if the service is busy. Like, that is something that it is possible for you to do at the HTTP level. So GraphQL actually, surprisingly, we'll mention it a little later when we get to the implementation. It doesn't specify a lot about the HTTP side of things. There actually isn't anything in the main specification about it. It's about the query language, about the type definitions. And so some of this will vary between different GraphQL servers and implementations. So in terms of, like, at New Relic, for instance, if you send us a payload and it doesn't have an API key attached to it, I think that we do actually send back a status code that is a bad request. It would be possible for you to get, say, 500 sort of error codes from load balancers sitting in front of the GraphQL. I think that the key point with it is just to, in terms of your application and your domain modeling, we've stopped thinking about HTTP status codes as being like the main way that gets conveyed. We model that within the errors and within the data objects of GraphQL, and don't lean on having a sort of HTTP-ish flavor to it. But if something goes really wrong enough, there are a few cases where you might get some HTTP errors back. So that is just a taster of the things that are in the GraphQL specification. I would actually recommend, if this is something that you're interested in, it is one of the more readable specs that I've come across. It's actually very clear, very well written, great examples throughout it. And so it's really accessible to go and look at it. And there's plenty in there that we didn't cover today, but we've got enough pieces now that we can sort of talk about some of the trade-offs and why we would choose this technology. So the biggest reason, like the big motivator behind GraphQL that drove Facebook to invent it in the first place, and that we definitely observe at New Relic, is that it has a pretty dramatic effect on reducing the number of requests that we have to make from our clients. So New Relic, our web UI, it has a lot of different things that we're trying to query data for. And GraphQL, by its nature, allows us to batch those up, take different parts of the screen, say, that we're wanting. We're like, hey, what features should you have? What's your user information? What's your account entitlements? We can ask for all of that in one batch, which is one request from the browser and then coming back. Now that fans out to all sorts of stuff, but it's doing it in our data centers. Like, that's fine. I don't care if it makes 100 calls once it's on my server, but I don't want my customer's browser to have to do all of that work. As mentioned, it also makes for smaller request payloads. Because people can make because you have to craft your query to ask for data, people tend to only ask for the things that they actually need. There's a penalty for sort of over asking because you've got to write all of that code and query for all of those pieces. And so those smaller payloads, that translates to better performance for customers. And as we mentioned, it allows for easier ways of growing. And that's key to us as well. GraphQL, by its nature, allows for additions into the schema. It's very much designed for you to continually add things in, and then you can remove things, but that's harder, right? So it gives sort of a path of accreting small things into this system, which, if you can imagine trying to do a RESTful service that is the single face to 50 different teams running their services, like versioning that and doing all of that correctly, it would get to be a nightmare. But GraphQL schema gives a really natural place for doing that sort of growth. And it does it while avoiding an explosion of different places that people have to look. You don't have to go find all of these different endpoints. You don't have to, run something like Swagger or OpenAPI, I think it's called these days, to sort of like find where the thing is that you're wanting, because GraphQL, by its nature with its schema, is very self-documenting. The schema that you author for your types and for those responses, it has documentation fields, it has things that all come out. There's base tooling that comes with GraphQL that you don't get with a RESTful service. Like GraphQL out of the box gives you that documentation at a system level, which is really nice for our customers to be able to know that anything that we put in there is already going to show up in our Explorer, it's going to show up in our documentation, all pretty automatically. All right. So how did we build it? So this gets into sort of the implementation side of things. And we'll talk a little bit about the libraries involved and what the code looks like. So fortunately for us, as I mentioned, there are GraphQL implementations across many, many different languages. In Java, it is very compellingly named GraphQL Java. There is pretty much the one entry that people have standardized on, rather than a fragmentation of different ways of doing it. And the library is really nice. They have done a really great job of making it easy to get started. It represents the GraphQL engine. So it is really the thing that does the evaluation of your query, that does the data serialization, and that understands how to do those parts. And so it doesn't deal with a bunch of the HTTP concerns and running it as a service. It's sort of like a standalone computation engine for GraphQL. Their documentation is pretty excellent, so I recommend that you go check it out. But as I mentioned, everybody expects this to get served over HTTP, and you start out with this library, and this library does not have a web server or anything like that anywhere within sight of it. So what are you going to do? Where do you go from here? Well, there is a draft spec, and there are a lot of conventions. Like I say, this is not in the specification. It is fairly well understood how people do this, and there are a lot of commonalities around how GraphQL is served over HTTP. This draft spec, I haven't checked in on it in a little while. It might even have moved beyond being just a draft, sort of standardizes on a lot of those pieces. And if you're using something very standard like Spring, there are things out there which integrate GraphQL Java and make it, surfaced over HTTP. So I would encourage you, especially if you're doing Spring, this is a great project that supports that. But at New Relic, actually, we had a lot of our projects which were for various historical reasons based on Dropwizard, which is sort of a Jersey-based framework. It's pretty, it does a lot of the things that we need, and so we kind of haven't moved away from it. And so we had to figure out a little bit about how to do this ourselves at that point in time. We also wanted to be compatible with New Relic's GraphQL service, which is called NerdGraph and is actually implemented in Elixir. And it had a little bit of, there were some oddities here and there about how it handled some things that we wanted to mimic. So it's not too difficult to get there. So in Drop Wizard, your various endpoints are going to be represented by resource classes. In our case, we would want to hand the GraphQL engine to that GraphQL resource. So the GraphQL object that we're passing in here to hand it, that's what comes from the GraphQL Java library, and we're just handing it to our resource for it to hold on to. Now, when somebody makes a call to that GraphQL resource, our responses are always going to be JSON. So we can do that across the board. Everything produces JSON out of this. We need to hold on to the GraphQL engine in our resource so that we can actually run requests when they come in. And then here's an example of one of the HTTP methods that's supported. So I showed earlier us posting in with the post body being in a GraphQL format. You can actually, it does support doing a get and doing query parameters for it. And so in this case, we would get the query parameters and variables and pieces that we want out of that. Our conventional path for all of that is going to be at /GraphQL. And then we actually, do whatever wiring we need, and then we call to the GraphQL engine, and it will return us an object which we can just hand back as a response to our clients and serialize back to JSON. All right, so that's a little bit about the HTTP side of things. This should hopefully be not too hard of a problem for most people, and increasingly libraries should be already there and you shouldn't have to worry about it. But then you get to the part where you need to make something happen, right? So you've defined a schema, something needs to fulfill that and sort of wire those pieces to your Java code. And this was where at New Relic, we felt a little bit of friction. This was one of the frictions that we had with the GraphQL Java library. It is extremely thorough. It has all the options that you could possibly need for being able to do anything that's in the GraphQL spec. If all you want to do is say, hey, when you call this field, call this other thing, it was pretty verbose to get that done. And 95% of the time, we weren't doing anything sophisticated and we didn't need all of that extra. So what we did is we've made a library, which is open source and available on GitHub and Maven, so called New Relic GraphQL Java Core, following along with the very creative naming. And the key thing that this library sort of does is wraps up some of those helpers that we found were really, really nice to have when spinning up a GraphQL service. So the primary abstraction that I like out of this library is the simple GraphQL builder. And so this replaces a lot of other, code that does the same thing, but is very verbose. So we create this builder, we hand it the schema, a reader with our schema defined in it. So that was like those type definitions that we were looking at earlier. At the end, we're going to say build, and that build is going to hand us back a GraphQL engine that's all wired up and ready to go. One of the most common things that we do is we say, hey, when this field on this type gets called, here is the Java class that you need to go execute. And we do that with what GraphQL Java calls fetchers. In other GraphQL ecosystems, these are often referred to as resolvers. So you may see that terminology around. It's called fetchers throughout the Java slice for whatever reason. So here we say, hey, I want to define a fetcher. Anytime that someone asks for the movie field off of the query type, here is the class that you use to go fulfill that. And so this query movie is going to be responsible for doing the actual work when that query comes in. So this bridges between sort of our schema and the definition there, and the GraphQL engine provided by the library is going to figure out that it needs to call that object, and it's going to call into it for us. So this is not restricted to the query type at the top either. This is one of the nice things about the implementation, is that any level in our type system, any field that we want to replace and have something intercept that and do some other sort of work, we can do that. So here for the reviews field on a movie, we have a separate fetcher. So you can imagine maybe there's a different review service that we have to go consult. A nice part about this is that if somebody doesn't ask for the reviews field, then we don't have to make that call. If your object just returns an object with fields on it, say the movie's title and ID, you don't have to make a separate fetcher. You can just return objects from it. But if you want to intersect get yourself into the midst of something and pivot what gets returned, it provides you with all of that. Mutations are also done in the same way. They wire up just by type and field, and they are provided by fetchers. All right, so what do these fetchers actually look like? So GraphQL Java supports a number of different ways that you can get your data back out. It's pretty smart about serialization and deserialization. We're just going to work with a plain old POJO. This talk was originally written before some of the record stuff came out. I would probably be inclined to make a record for a lot of these. But here we can see our movie class with all just the standard sort of stuff that you would expect it to have. No deriving from something that's off in the GraphQL space, none of that. It's just a POJO. Our fetcher then is a class. We're going to make an instance of it, and it's going to implement the data fetcher interface. Now, there are a couple different flavors of this, but here we're using the generic typed one where we can provide it the object type that we're going to respond with. And so this says, hey, I'm a data fetcher. When you call me for a given field, I'm going to return a movie. So the implementation of that is just going to be a public get method. It returns the movie type that we've asked for, and it takes in this data fetching environment. Now, this is like all of the context about the current query. It tells you, like, there's a lot of different stuff in there. There's things about where your parent was in the query. There's data loaders for doing lazy loading stuff. But for our purposes, the main thing that we care about here is that it has the arguments. So you'll remember that when we call to query for a movie, we need to ask for it by ID. This is the form that you would use to get that argument out of the environment, out of what was called, to get an integer for it. And here, I'm just delegating to another service to go do the actual database lookup or service call or whatever it is to get my movie back. You can kind of think of these fetcher classes like if you've worked in a classic sort of MVC sort of mentality. Fetchers are a little bit like controllers. You know, they probably are mostly about coordination of different pieces. They're probably calling out to other repositories or services. They're doing a little bit of light computation maybe on the input form of what's coming in, but they're not the home for all of the logic necessarily. It tends to be good when they're pretty thin and they're just sort of the glue between your domain and the GraphQL world. So at this point, we have a GraphQL service. It'll return that data. We can talk to it. We can ask for those movies. But there's something that bugs me, and we're feeling like we're kind of repeating ourselves. I mean, we already set our types, right? We told GraphQL that we have this movie type and what's on it. Like, why do we need to do all of this work restating things? And so that has led us at New Relic to do a little bit of investigation and work ourselves to create a API generating plugin. And what this will do is it will take a GraphQL schema and it emits Java code that will fulfill that schema working with the GraphQL Java library. So it's sort of a code generator that runs sort of, you can imagine it being like some of the annotation processors and things that are fairly common. The code can get checked in or not, depends on how you want to structure your project. But it understands the GraphQL schema and then has some support for being able to understand how to point that to various Java classes. It makes pretty much the sort of objects that you would expect. So any field that doesn't have an argument will just end up on the object's plane by itself with accessors like you would expect. And then anything that has an argument on it gets turned into a fetcher of its own. So you can imagine here we had our ID field. It can look at that and go, okay, so this is going to be a fetcher. It needs to take certain arguments and it's going to return us a movie. Well, it turns out that we can create a base class out of that does all of the argument munging, pulls all of those things out, and then our data fetcher can be very simple. It can just focus on the logic of what's going on there. Had a question in the channel about how to handle aliases in queries. So it's a good question. That's a part of the GraphQL spec that we didn't talk much about. So you can alias different fields and essentially rename them in the response. So you do it by saying like the alias that you want, colon, and then you say the field the way that you would have asked for it. That actually, a very nice part about that is that that is handled by the GraphQL engine itself. So we don't have to do anything in our types and in our responses. When we return the object response, the GraphQL engine knows the aliases that people wanted things remapped back to, and it takes care of it for you. So it's actually very seamless to handle and doesn't have to intrude over into your object model at all. You can rename and shuffle around and like do all sorts of stuff with the aliases in queries. In fact, it's often useful if you want to repeat a field. So like we mentioned earlier that you could make a search field, which is really, it's kind of not quite like a data model. Like it's not like modeling data. It's kind of like a method that you go invoke. Well, you might want to do 3 searches. Well, you can give each of those a different alias and then go ask for it to run all of them in parallel. The code backing it will be exactly the same, and the engine takes care of making sure the responses go back where they're supposed to. All right, so this API generation allows us to have a very, very thin sort of base class. It's opt-in. If you want to implement the fetcher entirely yourself and you don't want any of this help, you don't have to, but it generates those types to make it a little easier. This shows up even more, I feel like, on the mutation side, because mutations often end up taking a lot more elaborate objects in. So here would be a mutation that is the adding in a review, and that review input has, you have to tell it what movie and the score and the opinions, and you can see like we're doing all of this really ugly sort of like go get things out of the arguments, sort of destructuring that ourselves. Well, the generated code that we can get out of it based off of that schema, which tells us what all of these arguments are, means that we can just have our review input type and get that handed to us. So all of that sort of serialization of things or deserialization into Java objects can happen upstream of us, and then we can just write our domain logic. Now, I will say this library is something that we've talked about open sourcing. We open source the other with the helper libraries. This one we haven't made out into the open yet, but it's been discussed. So if this hits anybody's fancy and you really wish that you had this, let me know, and that might get some motivation behind getting it actually released. So how did this actually end up for us at New Relic? I would say that by and large, it has been a success. It hasn't always been easy, and there are things that we trade off in doing this, but it has been very successful at the big goals. So at New Relic, NerdGraph is sort of our central API, and our CLIs and various integrations, customers can write their own things against it, and our UI, it all drives through that same GraphQL interface. It makes it a lot easier for us to be API first. When we build something, we build the API for it that both us and our customers can use at the same time. This is drastically simplified. So the nerd graph sitting in front of 4 different stitched services, I think it's like 100 at this point. And that's actually one of the big leverage points that the team has had internally, is allowing for federating out to GraphQL services. So we get the goodness of being in that one central face that everybody on the outside can call, but we also get to run our own individual services that are just our concern, which is a super nice model for us. There are a variety of things in the ecosystem that provide some of that sort of federation. So Apollo is one of the big implementations of a GraphQL server and client in JavaScript. And there are some federated approaches around that that are really popular. Our implementation of it is actually purely internal for somewhat historical reasons, and also because it made some of the problems of doing federation a lot easier. So part of what's been good about GraphQL, I feel like, which is weird to say, but it's like, it's made constraints. Like And as an organization gets big and grows, like having some constraints around your API is actually a really powerful thing. It's powerful for helping you shape your customer's experience and shape the system. So for instance, errors, we brought this up earlier. In the very early going, a lot of teams, when we did something, it's like, oh yeah, something was forbidden. We're going to return a 403 in the GraphQL data, like modeling things like they were HTTP. We've moved very far away from that now, and we're able to give really rich errors that our front ends and our clients are able to consume and do much more sophisticated things with. We leaned into how GraphQL wanted us to model those errors. And I think that we've ended up in a spot where we can do much better than what we did before. We're able to very easily provide one messaging to customers, but have internal details that we can get access to if we need them. And that is all built into the base system. We don't have to re-implement that with every service or use a special library. It's just part of how the GraphQL works for us. Other constraints that you run into. So GraphQL does not have just a JSON type, but you could jam one in there if you wanted. Like you could make your own custom scalar and just say, it'll be a JSON object. Just put whatever you want in. But you lose all of that power. Like you lose all of that field traversal, all of the introspection, all of those other pieces. And so this has pushed us to be more descriptive in our type system. So instead of saying, oh, we're going to have just a like bago.json type that we have floating out there, we make specific custom attributes for things when we need them. So if we have something, and there are legit cases where like you have a model that needs a key value, like a bag of key value pairs, well, model that specifically as a scalar and make it specific to your type to distinguish it from other things that might have similar shape but be different. That typing has been useful for making better communication, better documentation, and keeping things cleaner in the API. Evolution is a huge part of any system, and GraphQL provides us some interesting tools for that. So one of the things that you have to do to embrace that is you've got to let go of strict versioning. So like it's considered good practice in a lot of RESTful systems to have some sort of strict versioning, whether it's based on headers or paths. You have your V1, you have your V2, and then if you're going to change anything, you make V3. That's not how you work in GraphQL. You just gotta let it go. As we mentioned earlier, it's designed for addition though. It's a different mindset around how you make things. So if you want to add something, you want to extend an object, adding attributes is safe because of the nature of the queries. Making a new field that maybe is a differently shaped version of the same data while maintaining the old version is perfectly fine to allow you to sort of evolve things and grow it. There are some bits that you can make breaking changes, though. Obviously, if you delete a field and it goes away, then that's going to mean that some queries that used to work now won't. And so we have a lot of restrictions actually in our system around not allowing you to remove things until you've proven that they're not in use. You can also make breaking changes with required and optional sort of marking things. So if an object has been marked as that it is non-null on the response, and then you start returning nulls because you changed the schema, or on the opposite side with inputs, you didn't allow nulls, or you did allow nulls and now you exclude them, those could break your callers. And so those are grounds for thinking really hard about your schema at the beginning. One versus many is another case. Like, is there any chance that somebody might want more than one of this object versus not? And you're better off if you model that as a list type, even if today the lists only have one thing in them sometimes. This whole system has allowed us a lot of power, like I mentioned, at least partially because we can centrally lint some of these things. So a lot of what I talked about of like, hey, certain schema changes are dangerous. Our linter will show those up and say, hey, you're making something required that wasn't before. That's a breaking change. And we've instrumented things so that we can tell exactly what is being used and not. And so we can track usage and go, okay, yes, this usage of this field is gone completely, so we can safely remove it. So if this is JSON message type, can you work with OAuth and JWTs? So yeah, OAuth and JWT or other sorts of authorization pieces, those are kind of outside of the GraphQL spec at the HTTP level, and you can certainly use those technologies to mix together. So New Relic, like we have API key authorization on the service, that's handled outside of sort of the GraphQL spec. So anything that you can do at sort of those HTTP layers, you can wrap around the GraphQL service pretty handily. So one of the last things that this has enabled us to do, and I kind of alluded to it, I think, in some of those pieces, is it also gave us a place for common patterns. So choosing the language that we use to talk to our customers in our API, having it in one schema makes it easier to make that consistent and see where pieces are. Certain responses, certain objects that we hand back can be shared between teams. So anywhere that you get a user back, you should be able to see all the information about the user, regardless what service that might have come from. Pagination is something that commonly happens with large volumes of data, and that's something that we've come up with good approaches that we apply consistently across our API. And as I keep banging on about the safe error handling, being able to do internal versus external, having that be systematically baked into the GraphQL service has been a really powerful level up versus the world we were in before, where every RESTful service kind of took its own path on how it was going to return errors, and it was difficult for people to manage. So that is where we've been today. We've talked about what GraphQL is, its type system, how you do queries, how it allows us to shape data. We've talked about some of the flexibility that it buys us that would make you want to choose it, and some of the things that maybe make it overboard for some purposes. We've looked at how Java allows us to implement that pretty easily, and heard a little bit about how New Relic did this and how it went for us. So that is what I have today, and I don't know if we have time for questions or if we need to move on, but I appreciate your time. Unrelated to GraphQL, I do have 2 books out, so feel free to grab a copy of them. Anybody who gets the Manning thing, you could pick up a copy of that. It wouldn't make me cry. So really appreciate your time.
Okay, does anyone else have any questions here for Jason? Okay, I'm not seeing any, so usually at this point in the presentation we have a little round of applause, so at least I'll clap. And then what we'll do is we will move on to the next part, and that will be the raffle here. So I think I'll go ahead and end the recording here.